Welcome to qnawire.
So in this kind of problem, we're considering a steady flow Carnot cycle with water as the working fluid, executing under the saturation dome within the limits of 3 megapascal up here and 10 kilopascal over down here. And the water changes from saturated liquid to saturated vapor during the heat addition. So we go from one to here, saturated liquid to saturated vapor up at the high pressure side. And we want to find what the work output of this cycle is. Well, the work output is going to be, we need to figure out first, I mean, there's various ways to figure this out, but we can figure out what the heat that we put in is just the heat of evaporation um, uh, for water going from, this entropy to this entropy, right? So we can figure out what H is here, and we can figure out what H is here, and then the heat input is just the difference in those H's, which is the enthalpy of evaporation, that we can figure out, assuming we can have some tables or something with this. We can figure that out to be 1,795 kilojoules per kilogram. We can also figure out what the saturation temperatures are here at these pressures. And up here at 3 megapascals, it's 507 K. And at 10 megapascals, it's 319 K. And so now we can figure out what the thermal efficiency, or the Carnot efficiency, is. And that's 1 minus the low temperature over the high temperature. And that gives us 0.371, or 37.1%. And now we know, again, that this is an ideal Carnot cycle. We know then the net work out of the system is going to be the efficiency times the heat input. And we can multiply this times this, and we get 666 kilojoules per kilogram. And that turns out to be answer A.